Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you're doing good. In this, we're gonna see target sum. It has been asked by Meta and Amazon in last 3 months, so it's important. Again, tags you can find in Telegram and Discord. Now, it says that you are given an integer array nums and an integer called as target, which means okay, nums array is given and a target value is given. Now, they are also mentioning that nums array all the elements are 0 or positive and the target can be minus 1000 to 1000. Now, you want to build an expression out of nums by adding one of the symbols plus or minus. As you can see, I can add plus or minus in front of any corresponding nums of I. As you can see, before every integer in nums and then concatenate all the integers, which means okay, after assigning a corresponding sign to them, just add them. Simply how we add integers. Now, for example, as you can see, they added a plus before 2 and a minus before a 1. It become plus 2 minus 1. They just have to evaluate this expression. Just it will become a 1. I have to return the number of different expressions that I can build which can evaluate to target. So as you can see, because obviously I have 1, 1, 1, 1, 1. I have two options. Either I can place a 1 or a 0. Again, two options, plus or minus. Again, a plus or a minus. Again, a plus or a minus. Again, a plus or a minus. So before every integer, or I should say nums of I have two options. Either I can place a plus or a minus. So what all expression is built after that, after evaluating that expression, if it matches target, then it's a good expression for me. I just have to count those number of expressions. So obviously I will have to go in a brute force naive way, which means okay, I will try for okay, placing a plus or a minus, placing a plus or minus, placing a plus or minus, placing plus minus, and then after placing, which means after having to explore n number of options, I will evaluate it then, which means O of n time again, and thus this with no time complexity. Obviously, if I see n is 1000, sorry, n is 20, which means that this kind of stuff, 2 raised to power 20 into n, like n, again, n is 20. This might work. But then you will like, okay, can I optimize this? Obviously, you can, because if you see that, obviously, for everything you had two options. Here you have two options, here you have two options, here you have two options. Now, if I ask you, if you had a plus minus here, what if you would have, again, you would have chosen one option plus here, which means to place plus here, right? To place here, minus here. You choose some option, and then now you have either you will place a plus or a minus. So whatever answer you had already stored here, why can't you use the same thing? Which means you can simply memoize something which you have already stored, and that is here we can simply get the hint of we have to do memoization. Although whenever you have options, okay, do xyz, like take not take, plus minus, add subtract, leave not leave, usually you have to memorize it and improve the complexity by using dp itself. So obviously I realize I can simply use a dp now, which means that if I'm using a corresponding dp, if I take the input, let's say that n1, n1, n2, n3, n4, so obviously I will have my corresponding index starting from here. I can simply start my solve function saying okay, I will start from the index 0 and my ultimate achieving number is target. But if you remember, I have to maintain what? I have to maintain what is the sum, because obviously I will take a number, I will assign a sign to it, then my task ultimately is to add that, which means after assigning the sign, I have to keep on adding it. So I have to also maintain the corresponding sum so far. That okay, after assigning a sign and adding that in my current number, what is the sum so far? So target is something okay, which is expected, which I have to do, but ultimately what is the corresponding sum I have maintained so far? That's one thing. And obviously I know I have to memorize it, so I should know what state to memorize. Obviously target is fixed, it is given to me in the input itself, it's fixed. I itself starts from 0 and will move up till n minus 1. So obviously I will have to memorize my I. And currently here in this case, the sum will also change. As I move on to every I, as I assign the corresponding sign to it, the sum will also change. So here the sum will also need to be memoized. Okay, so I simply realized that this is how I can call my simple recursive function. We'll go simple recursive wise. And we know that if it is recursive, starting from 0, ultimately what will the base case? Base case will look like, again, let's firstly write that I started my I, and then I, let's say, gave him the sum and the corresponding target. Sum is the current sum so far, I is the current index, and then target is ultimate maksad target. Now, as we simply know that we have to give a corresponding base case. The base case simply is when my I reaches what? When my I reaches what? Which means my I have consumed all the indexes, which means I have reached end. When my I reaches n is the end of the array, which is nums. Let's say whatever is the array size, nums dot size is my n. Then I can simply say, okay, now return 1. But no, you have reached end, you have to check if your sum matches target, because that was the condition for it to be a good expression. So I will have a match that simply return if the sum is equals to target, because if it is equal, it will simply return a 1, else it will return a 0. Again, there are multiple ways to frame it. If it is equal, then simply return a 1, else return a 0. So we realize, okay, we have to return an integer itself. Now, again, very basic fact that how we memorize stuff, that dp of I and then the corresponding sum, if it is not equal to -1, we usually do, then simply return dp of I and the corresponding sum. Now, again, this is how we do it. Again, I'll tell you this is wrong. Tell me why. Before that, okay, I'll just go on to the later part and then I'll come back to it later on. But again, comment down below why it is wrong. Pause the video. Again, this is very important to think why it is wrong. Now, what we will do? Okay, we have two options. Either I will assign a plus sign or a minus sign. When I assign a plus sign to it, obviously in the current sum, this will be added. And I go to the next index. So one option is add. One option is add. If I add something, obviously I will go and call and say I plus 1 and then sum plus, because I'm adding a sign, sum plus nums of I, and then target remains as is. So let's remove target. And then what if I subtract? Again, I will still move to next index, which is I plus 1, just that I will subtract sum minus nums of I, and then again move to next index. Now I have added it, I have subtracted it. For me, I want to find total number of different expressions. So for me, I have to return, let's say, subtract. So I have to return add plus subtract as my answer. But obviously, you know that you also should be memoizing. So let's change a different color. So I also know that I will simply memoize by saying dp of I comma my current sum, whatever I had. This is the, I can simply get the answer. Now coming on back, why is this not true? For any index, I am saying that I will by default assign the value of -1. Now, when I say by default assign the value, we usually assign this value considering the case that I will never repeat this value or I will never encounter this value in general cases, which means I am saying that add, subtract, I will never encounter this value. Okay, that sounds reasonable, because if you just look at it, add, subtract, these are kind of the number of ways. They will not become -1. True. But what about the sum? Aryan, sum. Oh, Aryan, true. Sum technically can be negative. Why? Because my numbers are positive, but I can assign a number being negative. So I know the number is 1000. I know the number is 1000. But if I assign the sign negative, it will become -1000. But now you might argue, but Aryan, the sum in total of nums of I is less than 10,000. Bro, the sum is input sum. This 1000 indicates this, which is all positive. They are just mentioning that in total, if I just club it up, it will be less than 1000. That's what they are mentioning, right? So one thing we realize, okay, the sum at a specific stage, which means while I am iterating, let's say this specific I, if I would have put up a negative sign, it would have become a negative. Now dp of I, which is positive, another state cannot be negative, which means you cannot pick a vector of vector. That's an issue here. There is a catch. Like you can do shifting. That's one way. Or ultimately, you can use a unordered map. Because for unordered map, the key need not to be positive. For a vector of vector, because vector of vector is based on indexes needs to be positive. But if I just take this as my key of an unordered map, that will work. So what I will do, I will make a vector for this and the corresponding unordered map for this. Unordered map key is this, value will be this. Again, for unordered map, I don't have to by default put a default value. I can simply check if it is there or not, right? By simply checking if the value exists or the key exists or not. That is how I can check for unordered map. So I realize that I can simply use an unordered map in this case, right? That, okay, vector, again, either you can use an unordered map of unordered map, or you can also use a simply vector of unordered map, right? And I'll use the same thing, vector of unordered map. I show you the corresponding code also. Let's see, this is the only catch which you had to make sure. So ultimately I made a vector of unordered map saying int. Now this thing indicates the corresponding index, this thing indicates the corresponding sum, this thing indicates the corresponding value, or I should say the count of number of good expressions. Cool. And ultimately I will call my solve function saying the index, then current sum, the target and the DP will remain as is. Then I will have a base case condition. If my I has reached the end, simply return that if the count is equals to, if the current sum is equals to my target. If yes, then simply +1 or else -1. Again, you could have simply shown like this also, but yeah, all right, it is the same thing. Check, base case check. If my DP of index, which is the vector, map, it is a hash map, or I should say unordered map, count of current sum, count indicates if the key is there or not, that's it. Return the corresponding answer if it is there. If it is not there, simply go on forward, which means add. If I add it, then solve it for the next index, adding the value. If I should subtract it, solve it for the next solve it, going for the next index, but for the current index, subtract the value. Again, I want to find total number of expressions, so simply add plus subtract is the total number of expressions. I'll simply memoize it and get my answer. Now, because considering you are using DP and the only thing changing here is index and the current sum, thus my total corresponding time will be n, which is for I, and current sum in total can actually go to the total sum. So sum of nums of I. Now, Aryan, what in this is actually n, which is 20. That's true. What is this thing? Sum of nums of I. As I told you previously also, they have already mentioned that the nums of I, that my nums of I is 1000. And technically, even if, again, in the very beginning, all of them are positive. In the beginning, all of them are positive. Even if I add all of them, still their sum will be less than 1000. So in worst case, my total sum in positive direction can go to 1000. Now, if I ask you same thing in vice versa, if I would have put all of them sign as negative, in worst case, the total sum can also go to -1000, right? Thus, my total sum actually has also a limit of -1000 to 1000, ultimately giving that this sum value ultimately can actually be at max 2000 distinct values. Thus, my complexity will be 20 into 2000. And same way, obviously, for space. Now, obviously, the interview asks you to optimize it, which means that whenever you are given a corresponding DP code, you have to optimize it, which means you have to convert it to a bottom of code. Simply do the exact same stuff. I'll use the exact same code. Again, I'm erasing it because I want to use the exact same code, right? So let's see. If I want to use this, I know that my DP state, how it should look like. I am at index I, at the corresponding current sum. I should actually take up I plus 1 and take up current sum plus nums of index. Same way, I plus 1 current sum minus nums of index. Again, take a snapshot of this because I don't have that much screen. I'll show you the other side, how I'll change it. I did the same thing. I am at I and I said that simply I will go on for a corresponding I will go on to its next value, which is I plus 1. I will get its corresponding count. And then I will simply say, okay, for the current I, sum plus nums of I will go to I plus 1. Thus simply get the corresponding count from there. Same way, I, sum minus nums of I, get the corresponding count from there. And again, this is the corresponding base case I have just put up, although it's not required because absolute sum of target will not be more than my total sum, but it can be. That's okay. Why is that the case? Because what if the target is 1000, but technically what if my nums of I is, let's say, 0101, very small values, and let's say n is also 20. So obviously the sum in total will be 20 itself. But no matter if you add all positive or all negative, still you will never be able to reach 1000. That's the reason, a simple base case, that if your absolute value of target itself is more than your total sum, because again your total sum is technically all positives. That is the reason you are comparing it with the absolute value, and if it is more, simply return a 0. So that's a simple base case which you have put up. And again you have to also put up the corresponding same DP. Again, I will come on to this base case, no matter, like, no worries. But technically you are iterating from the very back side. You can do it from the left side also. I will show you just in a second. But just to match with the current statement, as I was also doing one thing. Okay, for any index I was simply checking the corresponding I plus 1 and making sure in the current index I am adding my current sum plus nums of I. And ultimately I was getting whatever count I had. I was simply adding that corresponding count in DP of I and current sum. Right? Same thing I did here, that I know for the current index. Again, there's a slight catch here. You'll see, okay, I'm adding sum plus nums of I, but here obviously you are adding current sum plus nums of I, obviously for the current statement, and then moving on to the next statement, and then adding that current thing here. Same thing, I add the corresponding count from my I plus 1, add it to myself, and you will see I'm iterating from the backward side. Now, if you want to see the same thing by forward, that makes more sense. That makes more sense. But again, this I showed you so that from top down, you can convert to bottom up fast. But technically, always people will discuss this one, left side one, this one, because it actually makes more sense to understand how. Let's see. So obviously, this case we already saw that it's a simple base case, which will be there. And here, to compare the base case, I had to find the total sum. Then obviously I will have to take the corresponding same unordered map, or I should say vector of unordered map. Now comes the base case. Obviously there should be a base case here. Now technically you might say, what does base case even mean? You will come on to it. But what this base case here mean is that taking no element, getting a sum of 0. How many ways are there? Obviously there's one way. Don't take anything. One way. And that is to replicate the same thing. We had to write the same condition. Again, technically that doesn't mean anything. Taking n elements but no sum, one way. Obviously, take no element. But still, it makes more sense. Taking no element, having a 0 sum, gives us one way. And now simply iterate on all the elements. Technically, again, index here is from I equal to 1. But I'm taking one element, then two element, up till n elements I am taking. So you will see that the current number here is nums of I minus 1. Then as I know that I have to go back and check for my different previous numbers. So I'll simply iterate my dp of I minus 1, which is simply nothing but an unordered map. I will check the corresponding sum and count. This will help me that what was the sum, what was the count. And then I will say that in the existing sum, add the current number. In the existing sum, subtract the current number for the current index and add the corresponding previous count to get the new count. And it will be relating with the same concept, that simply adding the corresponding count, right? And ultimately I have, my maqsad was for n numbers, considering n numbers and achieving value of target, how many number of ways are there. So simply return this value. Cool. Again, you will see that exact same stuff goes on here also. It's just that to understand this specific line, you have to understand it is nothing but a replication, or I should say, just to incorporate this specific case, I have to put it like this. And again, to build this, I can take a reference from top-down approach. Right now, again, you might say, Aaron, the time and space both remain same, because obviously in this case also my time and space both are same. So how do you optimize it? Yes, but always bottom up gives you a freedom to now think of how you can optimize it. Why? Because if you look for very carefully or very clearly, you will simply realize for any index I, you're only referencing I minus 1. That's it. So why do I even need to store all corresponding DP values, right? Which means for all indexes, why do I even need to store it? That's the reason. What I can simply do is I can eliminate and just take two indexes, current and previous. Again, to replicate this scenario I have taken current and next. To replicate this scenario, I have taken current and previous. Sorry, current and previous. Cool. I'll show you. Let's say this one. Again, you can also compare this one on side. Again, exact same code, just changing the corresponding by eliminating the index, all the indexes, just taking two indexes, current and next, and here current and previous. How do I do it? Simply, the only change here is taking one unordered map, or I should say two unordered map, current and previous. Here the base case changed to previous of 0 as 1. As you can see, previous is the first index, so this thing changed to previous, and then 0 is corresponding sum. I have one way to achieve a sum of 0. Take nothing. Then I go on to all the elements. As you can see, I went on to simple all the elements in the simple order. As you can see, I'm going on to all the corresponding elements. Then I will simply go on and check the number, actually the sum and count in the previous. Same way I was doing here. In the previous I was going checking in sum and corresponding count. Then exact same code. Sum plus nums of I, sum minus nums of I, add the corresponding count. And before you go on to the next for loop, make sure to assign your previous with the current value. So here, as I go on to the next for loop, I should make sure that I will be referencing dp of I minus 1. So I should assign my current, which is dp of I, because see, current is, if I show you, current is dp of I now, previous dp of I minus 1. So dp of I should be assigned to dp of I minus 1 for the next iteration of the loop. And ultimately, I can simply return my prev of dp of target itself, which is nothing but here, dp of target. I can simply return, which is, again, you might say, okay, why not the corresponding current of target? Simply see that if in the last iteration, whatever you would have assigned, previous or current, both will be same, because in the next iteration, as you would go and your target, because see, in the last iteration, your current will have some value, let's say x. Your previous will also have some value which you will override with x. You will go on to the next iteration, it will not go because it was the last index. Both prev and current were same. So technically you can put anything. Yeah, it makes sense to have current of target. That would make much more sense. But yeah, that's a simple iteration. And again, the same way you can also put it here. Exact same stuff. Cool. I hope you guys got it. I hope you guys got the actual part, which is the most important part, is getting the top down ready. There is a slight catch. You have to make sure to actually incorporate the bottom up, but usually I recommend that again, there's one way I think for that, just converting bottom up from top down, but it is also easier to actually incorporate the base cases if you think of from the very scratch. That is possible here also. Cool. I hope you guys got it. Bye bye, take care. If you liked it, make sure to like it, and see you in the next video. Bye bye.